Hello, this is the seventh video in a playlist I'm calling Generalized Linear Models. And this is a total follow-up video to part one on Probit Regression. And here we're going to use R to run Probit Regression from scratch, meaning using the iteratively reweighted least squares approach. And then we're going to compare our results to what R has using their GLM function. And the data I searched, Probit regression in R, and the data from a UCLA site or a website from a UCLA site popped up, and there they had a link to data, and so I'm going to borrow that and then compare the results with what we get. So let's load the data. And this is what it looks like. There are four columns. Admit is going to be our dependent variable. We're going to try to predict whether we should admit someone or not based on the GRE, GPA, and rank. And we need to create a data matrix. And here I added a column of ones because this is beta 0, beta 1, beta 2, beta 3. And if we look at a Probit regression analysis, we're not going to analyze what each of the parameters mean or anything like that. We're just going to try to estimate them. So in here, this column, the estimates are beta parameters, beta 0, 1, 2, and 3. And these are the standard errors associated with each of these beta parameters. Now, in the video, part one, step one is we have to come up with estimates somehow. And here, I create a hollow matrix, W and G, which will be diagonal, which you'll see down below. But for estimates, I just estimate our beta parameters to be 0. And, all four of them. That's step one. And then in step two, we need to estimate everything that we need in solving the weighted least squares regression. So we need the W's and the Z's. And so first we get an estimate of eta. So that's our linear combination. So our data matrix times our beta parameters, which should be all zeros because we're estimating beta to be 0. And then we need to estimate mu, which is the CDF evaluated at eta. And if you remember, the link function here is the inverse CDF. So you take the inverse CDF of mu and you model that with the linear combination. Well, this is the inverse of the inverse CDF, and so we can back model or back solve for mu this way. Then we create a diagonal matrix G it's the first derivative of our inverse CDF evaluated at mu, but the derivative then becomes 1 over the density evaluated at eta. And then Z, we come up with an estimate of Z here, and then we need to estimate W, which is 1 over the square of the derivative of the link function, and then times the variance function evaluated at mu. Then we can solve for beta, and then we repeat it until convergence. And I just do it 20 times 20 times. And then beta is our estimates for beta. And then I print out the coefficients from the GLM model and look at that. They're accurate to 6 or 7 or more decimals. Now the way that we did this here is very inefficient, and you should always pretty much use the R default function, GLM, and then binomial probit link. But this is to illustrate what's going on behind the scenes. And now let's see if our estimates for the standard error is correctly. Now what it turns out to be is in the beta step, and we kind of get it by default, is x prime wx inverse, and that's this function here. So that should equal, and if we take the diagonal elements and square root them, that should equal the standard errors here. And so let's see. And look at that. They are exact to so many decimals. Well, anyway, I hope this video was informative. I think it's all so fascinating how the stuff works behind the scenes. If you liked it, please like the video and subscribe so you don't miss the next one. Thanks. Bye.